Okay, so today we're going to introduce you guys to matrices, which is one of our honors topics that we do in Secondary 1. So, first of all, let's introduce what a matrix is. So a matrix is a rectangular array of numbers and it's arranged in rows and columns. So for example, and they always have these big square brackets, like this would be a matrix. And you might have seen them before, and you might not. That's just a matrix. Basically, it looks kind of like a table of numbers, right? That's all a matrix is. A matrix is generally labeled with like a capital letter of some kind. So for example, if I use capital A for the matrix, I could call this matrix A. Okay, so I can say that matrix is matrix A. Makes being able to differentiate multiple matrices much quicker. And matrices is just the plural form of matrix. So when you hear matrices, that is referring to more than one matrix. Okay. So the next thing, and this is one of the more important things about matrices, is the dimensions. The dimensions of a matrix is row by column. Okay? And this is going to be a very important part of matrices. So the horizontal is what we'd call the row. So rows are horizontal, while columns are vertical. So like from here to here, that's a row. Okay? From here to here, that's a column. Okay? So rows, first row would be 1, -2, second row, -3, 4, third row, 5, 6. First column, 1, -3, 5, second row, -2, 4, 6. Okay? The numbers in a matrix are called elements. Okay, so like if I'm just looking at 1, that's the element of the matrix, number 1. Okay? And when identifying elements of a matrix, the first number of the subscript is related to the row, and the second number is related to the column. So if somebody gave me this matrix here, for example, and wanted me to find the element B13, and that's B13, and sorry, I'm going to zoom in here a little bit so you can see it better. Okay, that is B13, it's not B13. It's B13. Okay, so what it is saying is that is the element that is on the first row in the third column. So I'd go to my first row, third column, B13 is 3. Okay, that's how I identify that element. B21, I'd go to the second row, first column, so B21 is 0. And that's all it's asking you to do there. That's just identifying the element. Okay, so not too tough of a thing. Like it's going to be a lot of new like vocab in this unit, but matrices themselves are not too tough. Okay, let's keep going here. So next thing is when it says to describe the dimension, it means to use context for the rows and columns. So for example, let's say I have the matrix here. And let's say we have it representing like a restaurant. Let's say it's the number of people that order spaghetti, noodles, I don't know if I how to spell spaghetti, or fettuccine noodles. I definitely don't know how to spell that. fettuccine, something like that. Okay, and then let's say we also have people that want the marinara sauce, the red sauce, and I have no idea how to spell that. Marinara, maybe, I don't know, or Alfredo. I think I can spell Alfredo. I probably picked the wrong things to do here. Okay, so there's my matrix. So that is a 2 by 2, and again, matrices are always expressed row, then column. So this is a 2 by 2 matrix, right? There's 2 rows by 2 columns. And what it wants me to do to describe those dimensions is just say what the rows representing by what the columns representing. So it'd be like noodles by sauce, basically. It wants you to describe the dimensions. So that's not going to come up too often, but it might come up in this introductory part. Okay, next thing, if a matrix is equal to another matrix, then their elements are equal to each other. This is a big key thing. You're going to need to remember it for secondary 2 as well, because this comes up a lot in secondary 2. So, for example, let's say I have my nice matrix I've been using, 1, 2, 3, 4, and let's say I know it is equal to this matrix over here. Let's say it's A, B, C, D. So let's say I want to figure out what C is equal to. Well, C would equal the same element in the other matrix, right? So this is in row 2, column 1. So row 2, column 1 is 3. So C would have to equal 3. Okay, not too tough, right? D would have to equal 4. B would have to equal 2. A would have to equal 1, right? It's not too hard of a concept. Now, sometimes that might look a little bit different. So let's say I have a 1 by 2 matrix. So let's say x plus 4 and 8. So there's 2 elements there. This is 1 element. It's a 1 by 2 matrix. And it's equal to 5 and y, or let's just do, no, 2y. Let's not make it hard on ourselves. Okay, 2y. Okay, so again, these elements are equal to each other. So that means the first row, first column is going to equal the first row, first column of the second one, right? So x plus 4 has to equal 5. Well, if I wanted to solve for x, I would just minus 4, right? And x would equal 1. So again, this element has to equal this corresponding element in the other matrix because I know that they're equal to each other. Same thing here. 8 has to equal 2y. So if I want to solve for y, 8 would have to equal 2y. I would just divide by 2, and y would equal 4. Okay? Not too tough, right? That's the basic idea of the elements being equal to each other. So that's going to come up quite a bit on the second day. In fact, let's look at those and see if there's anything I want to go over on that one. No, that's pretty much what I just went over. Some two-steppers. Okay. Yep, that should be pretty much what you need to get through the first few pages here. If you have any questions, of course, you can always ask your teachers. We're here to help. We want to help. You just got to let us help. So I will see you guys out there.